And we're live. Okay, everyone, this is lesson 4. We're going to be going over methods and classes today. Um, I'm actually a little worried about this class. Out of all the topics that we've gone over, this is easily the most difficult to teach. It's very abstract, and it requires you to think about programming in a different way. Um, this concept took me about 2 or 3 years to understand, so I'm going to try my best to explain what's going on here, but I really, really need you guys to be upfront and forward about any problems that you may be having. Oh wait, I don't know why this is going. What's going on?
You see a picture of you.
I'm like hearing myself right now. Can you guys hear me?
Yeah.
Oh, that's because I had another window open. Anyways, so we are gonna be going over methods of class, like I said, and I really do need you guys to be very upfront and stop me if you have any questions about what's going on. This is the basis of why object-oriented programming is called object-oriented programming. So it's really important that we understand what's going on here before we can get into application development, which is what we want to do. So here we go. Uh, if you remember, I told you about this magic garbage up here, public class first lesson, and I told you that it was going to be explained at some point. Well, today's the day that I'm explaining all of that. So, if you look at a method like this main method here, you can think of it as a collection of instructions. For example, now over the lessons that we've done before, you guys can kind of parse what's going on here. I first declare a variable called I that's of type integer, and I set it to 0. Then I add 1 to I and save it into I. So now it was 0, now it's 1, and then I'm going to print out I is currently and plus whatever the I value is. So you'll see at the bottom here that it says I is currently 1 whenever it decides to run. So what you can think, yep, here it is. What you can think of this as is a collection of instructions. First declare a variable, then increment the variable, then print out what the variable is. So every time that the main method is run, this collection of what are the statements is run. So you can think of a method as a collection of statements, right? Now I haven't really showed you guys how to make other methods yet. That's also going to happen today. But there's another question of, well, if a collection of statements is called a method, what is a collection of variables, right? I showed you guys what it looked like before in the last lesson in arrays. But arrays work for like primitive values and a bunch of other things. But what about instead of having to declare an array with a fixed size, what if I wanted to have a collection of lots of different types, right? Because if you remember, arrays look something like this. And all of the elements in the array, that is what's inside of the array, it's also known as elements, all of the elements of the array have to be of this parent type, which is integer. What if I wanted to have a collection of different variables that weren't of integer, but I wanted to have them in the same object? That's where classes come in. Classes hold a whole bunch of different typed variables into one collection. So a method holds a bunch of different statements together, and a class actually does a lot more than this, but just to kind of distinguish between the two, a class holds a bunch of different types of objects into one neatly packaged um, class. Is anyone confused so far? There's also the chat window available on the side you guys can use. It's the blue icon on the top left of Hangouts. Is anyone confused? Should I stop? Okay. So now we're going to talk a little bit about the idea of what a pointer is. Now, you guys have already used pointers before with string variable, but I'm going to go into a little bit more depth about what a pointer is. So in the variable types that I've showed you guys so far, the types include things like, talked about int, about floats, and chars, and strings. Right. So with the exception of strings, these first three are considered what's called a primitive type. This means that they are not objects. And a char, and then you wanted to package them up together into one object, that object will be made up of the primitive types of an int, a float, and a char. Strings are actually arrays of chars. They're objects that have an array of char inside of them. So when you do a char at, that method actually iterates through the array. Well, it indexes through the array. It finds a very particular index in the char array and it gives it back to you. So if I had a string like this, and I do, it's basically the same thing as doing something like this, right? Um, this array holds a bunch of numbers. This array holds a bunch of chars, right? This string char at dot 0 gives you the h. Array 0 gives you the first number here. Now, the difference between these two things is that this string is a character while an array is another primitive type. How objects work, right? Like this string is an object. Sorry, that's what I meant to say. This string is an object. How objects work is that their variables, instead of pointing directly to the value, so here, I told you guys originally that, I'm going to delete this so it doesn't give me a warning. I told you guys originally that it's like digging a hole, right? Variables like digging holes. You first dig a hole and give it a label, right? So I gave the label I, and then you give it a shape, which is integer, right? And then you can put things that fit the shape into the hole. So because 0 is an integer, it fits the shape of an integer, and you can put it into the hole, which is labeled I. Objects work differently. Variables that are of type, that are object types, actually what they do is that they point to a location. So where this is an actual hole, this could be like a signpost. You have the same garden. When you do int I equals 0, you're digging a hole in the garden that's of the shape integer and putting a 0 in there. When you have an object type, it's like you put a signpost that points to all the different holes that make up this object. Okay? So this string is actually full of lots of different, they're called variables, instance variables, also known sometimes as properties, but properties are a little different. So inside of the string class, it has like an array of chars. It has all sorts of other primitive components and object components that make up the string class, right? So each of those instance variables points to a different location where the variable sits. What this means is that you can actually have two variables that are object typed point to the exact same value without overriding them, right? So if I did, I actually have to do it this way. So I have, so I first declared a variable called this string. When I use the keyword new, I'm saying that I'm allocating a new pointer location. This is like saying, hey, instead of just a hole, I'm creating a signpost, right? And that signpost is going to point to a valid object. And this object is going to be a string. And in that hole where the signpost points to is going to be hello. And then second string is another signpost, and I'm pointing it to the same place that this string is pointing to. So we have one guy in the garden pointing to a hole, and then the second guy is told to point to the same hole. So why this is really important to distinguish is because if I change what's at the end of the hole, the value in the hole, right, you also change what both of these variables are pointing to. So this is really useful, actually. You can imagine it like, let's say that you have a variable that holds a password, right? And then a second one that holds a new password or a verify password, right? So if the original password changes, right, this original value would change and this second value would change. So you can actually have these two things pointing to the same object so that you don't need to do a swap or a reassignment here. I think it's actually best if I just show you what a class looks like and then we can talk about it. I'm not sure where Kevin went. Does anyone know where Kevin went? Guess not. He must be watching it on YouTube or something. So that was a lot, I know. We'll step back for a second and I'll show you what it looks like to actually declare and create a class. So if you want to create a new class, it's actually pretty easy. You need to go outside of the scope of an existing class. You just need to write right outside of any other class. So you remember the scope is shown by the open curly brace and the closed curly brace. So if I want to create a new class, it has to be outside of this curly brace and this curly brace. So I'm going to create it out here. And I'm going to call this class animal, okay? So the first thing you do is you just say class, and then you give the class name. So I'm going to call it animal. And then you have to give it a scope. So open curly brace, close curly brace. So now I've just created my first class called animal. Now, you have to give different instance variables for that class. Now, these are the things that make up the class. Like I said before, methods are a collection of statements. Classes are a collection of variables. So what kind of variables do I want that make up an animal? Well, I'm going to do things like int legs, right? And let's do a new variable called bool. I think it's actually this. Boolean? Is it Boolean? I forget what it is in Java. There it is. Boolean is a new variable I haven't showed you guys. The only value a Boolean can have is yes or no, true or false. Let's see, what else do I want? Age, right? And let's say I'm gonna give it a string, and the string is called name. Now, whenever I create a new animal, it's gonna have legs, it's gonna has a head, it's gonna have an age, and it's gonna have a name. So now that animal is here, I can use it just as another type, right? So I do animal, this animal, and here's the distinction. You have to type in new animal, open and close, right? So now I have a animal, a variable called this animal that's a type animal. If I want to access these parts of the class, you have to use what's called dot notation. So if I do this animal dot legs, I'm referring to the value that's being held in legs currently. Okay, that's what's going on. If I wanted to talk and refer about the age, I do this animal dot age, and now I am referring to this variable here. Now the really important thing to note is that a class is a blueprint. It just describes how to make an object. So these variables actually have a brand spanking new value every time you create a new instance of that object. So animal is a blueprint. Creating an instance is like taking the blueprint, sending it to a factory, and then the factory creates that object. Okay? So I say, hey, computer factory, I want to create an object called animal. And I want to call it this animal, and I want you to make it right now. So your computer factory says, oh, cool, I have the blueprint right here because you declared class animal. And I know that an animal needs to have legs, has a head, age, and name, right? So if I create two of these guys, they will have exactly the same instance variables, or IVARs for short, but they will be separate IVARs. So if I did this, right? So I just created a variable called this animal that's of type animal, and I instantiated it, or I sent it to the factory. Instantiation is a fancy word that means create the object. Okay, so I first declare the variable, I give it a type, that's the class that I just created. The new tells the computer I want to instantiate a class, create a new object, and then I call the class. This is actually really special. I'll talk about this in a second. I then take that variable, I go to its age IVAR, which I declared here, and I set it to 10. All right. This is just like if I did int age, right? And then I did age equals 10. It's just that this age variable is now packaged in the animal class. All right, I'm going to stop here and see if anyone has any questions. I don't want to go too far. Does anyone have any questions so far? Are you guys lost? This is a lot of material so far.
Well,
Yeah.
so pretty much up there, you're just setting up the class.
You mean here or up here?
Up there, like what's going on up there?
So I'm telling the computer, just like declaring how you normally declare a variable, you need to give it a name and a type. The
Okay.
type of this variable is animal, right? So when I tell the computer, hey, I want to create a variable of type animal, it says, cool, I'm going to create a new block of memory or a hole that's of shape animal. And I know how to create the shape animal because I know what parts the animal is made out of. So first, I'm going to dig a hole that's of shape int and call it legs. Then I'm going to dig a hole that's just shape boolean and call it has a head. A shape int, call it age. Shape string, call it name. And then that really big hole that's made up of all these four holes, I'm going to name animal. So when
Okay.
I say this animal is of type animal, your computer then digs the necessary holes or allocates the memory that fits exactly this amount of space in memory,
Got it. So
right?
yeah, okay.
And then when you say new animal, you're telling the computer, hey, fill that hole so that I can actually assign things to these holes, right? So first thing the computer does is just dig the hole, and then it actually assigns those holes the necessary like initial values so that you can assign them later or read from them later. You understand? Is that clear?
Yeah, can you clarify what Boolean is?
Oh, Boolean is another type of variable. Sorry, I didn't really show you what that guy's is. So if I type in Boolean, this is just like any other variable. It's a primitive type, so it's not an object. Um, the only values a Boolean can be is true, true, lowercase true, or false. Okay. And if you use it in an if statement, you can do if is true, right? So since I set is true to false, this if statement, the condition is going to return false, so this is never going to fire, right? When you see it run, you'll see that it is true actually never runs. There's nothing here. But if I change is true to true, you will see that this prints out. It is true. So Booleans, the only thing that they can be is true or false. That's it. Got it?
Yep.
Okay. Any other questions, anyone? Okay, cool. Moving forward. So let's say I created a second animal, and I'm going to call it second animal. And I'm going to give second animal the age of 20. All right. Now, if this animal dot age is equal to second animal dot age, right? So you notice a lot of things are happening here. I first created a object called this animal and instantiated it, created the object. And then I set that object's age ivar to 10. I created a second variable called second animal, that's of type animal, and then I instantiated it here. I then set its age ivar to 20. This condition checks those values. So if this animal.age is equal to second animal.age, this will print out. Okay. Now you'll notice that they don't. If the age values in both were shared, this would have resulted true. What I mean by that is if it was something like this, right? If I would have done, see, it refers to the same variable. Even if I did this, right? It also would have resolved to the same. But because I instantiated two separate objects and I assigned their age values to two separate things, this isn't going to print out, right? Because you're asking, is 10 equal to 20? And you'll see nothing prints out here. If I change second animal's value to 10, 10 equals 10, therefore they are the same age. Okay? I can do this for anything. I could do it for has a head. I could do it for legs. So I could say this animal legs has 3 legs, and the second animal has 2 legs, right? Nothing. Nothing shows up, right? Because this doesn't equal anything. Oops, actually I need that. So now I'm going to explain what this means.
Paul, I had a question.
Yes, please.
So this animal and second animal are objects.
Yes, and they both hold different holes. These holes are completely separate from each other.
And those holes are variables?
Yeah, right. So this animal is a variable of type animal, right?
Mm-hmm.
And inside that hole are 4 other holes that have different names. 1, 2, 3,
No,
4.
but you said this animal and second animal are objects, not variables.
They are objects, right? But these variables are holding objects, whereas the previous variables I showed you, int, float, char, are holding primitive types.
Ah, okay.
Yeah. So you can think of primitive types as just being like, they just hold values. They're just buckets that hold straight up values, where class types hold other primitive types inside of them. So these are collections of primitive types.
Only primitive types.
Well, you can actually have other objects and objects as well. You can do that. But we'll get to that in a second.
Okay.
Okay? All right. So now we're going to get on to methods. Along with holding a collection of properties or instance variables, classes can also hold collections of actions. So if a class can be thought of as an object, its instance variables can be thought of as its nouns, things, people, person, places. It's just the stuff that makes up a class. The methods of a class can be thought of as the actions or verbs of a class. So what does an animal do? Well, an animal will run, right? An animal can speak, okay? Have to do something special here. I'm going to explain in a second, just to make sure that this compiles. Oh, sorry. Okay, they got it. There are people at my place. They're playing board games earlier. They got locked out. So these methods, right, are things that an animal does. And to run these methods, you have to have an animal. Okay? These are also sometimes called instance methods. All right? As opposed to static methods. You'll notice that here this has the keyword static. You do not need an object to call a static method. You do not need to instantiate an object in order to call a static method. For instance methods, methods that do not have the keyword static, you need to have an instantiated object to run the method. So now that I've declared these methods, you notice that I use the word public. I'll explain what this is in a second. And then the method name, right? Now that I have this method, I can then run what's inside this method. So when the run method is called, I'm going to have it say, I am running. Okay, so when this block, this scope of the run method is executed, it'll print out, I am running. How do I run the run method for a class? Well, it's simple. First, you have to instantiate an object of that class, which I've done here. This animal, new animal. Then you do the variable name, this animal, just like we did earlier. And then the method name, which is run. Open and close parentheses. That's very important. Open and close parentheses tells the compiler this is a method, semicolon. So you will see that when I run this, I am running. Okay? You have to instantiate an object before you can run an instance method for that object. Okay? So you'll notice that I said that if it has an open and close parentheses, that the compiler is told this is a method. Well, that's what's happening here. The special thing is that when you have a method that's the same name as the class, it's called a constructor. The constructor method is responsible for giving the instance variables of that class their initial values. So how you create a constructor is you just do public space the class name animal, opening and close parentheses, and then curly brace. Then you can give initial values to the instance variables of that class. So I'm going to say every animal, just to start out, has at least 2 legs. And every animal has a head. And every animal's starting age is at least 1. And the name of an animal is going to be animal. Okay? So what happens is that when I tell the computer factory, hey, build an animal, it's going to look for a constructor. And I've just provided that constructor. And this constructor is going to set these values to their initial values. And I've said that the initial values of legs is 2. So every time a new animal is created, its legs field is going to be set to 2. Every time a new animal is created, it has a head field is going to be set to true. So on and so forth. So you'll see that if I do a system, well, I'm going to do this, int legs equals this animal dot legs, right? You'll see that this comes out to 2, which it does. The number of legs is 2. Okay? You'll notice I didn't do this. I didn't do this, right? But how was it set? How I didn't run this line, I didn't type it before, but how does it know that legs is 2? Well, it's because the constructor set the initial value of legs to 2. Right? If I did it for age, age is 1 because I set its initial value to 1. Questions here?
Hey, Paul.
Yeah.
Why is like the class and all the constructors below? Why is it all like in the bottom instead of like the top? Because generally, doesn't the script run from top to bottom?
Yes, that's true. The difference is that when the compiler runs, right, it checks to see where all the classes are, and
Okay.
then it bundles them as separate objects. So whenever you call them, it runs top to bottom within the object, within the class scope. Usually in Java, programs will not run unless their file name and their public class name are exactly the same. Okay, so this file name is called firstlesson.java, and its class name is firstlesson. But this is why I didn't say public class animal. If I said public class animal, the compiler would complain because public class animal needs to be in a file called animal.java. Got it?
One more question.
Yeah.
Does Java remember any of the stuff like that you defined? So each time you run script, is it like automatically resets?
Yeah, so as long as you haven't changed the source code, and by source code I mean what you've typed in the program,
Hmm.
nothing will change.
So
Right.
I noticed that, you didn't have the, public animal, whatever, constructor, right?
Mm-hmm.
And then you ran, and, this animal didn't have legs, but all of a sudden, because you typed it in, the second time you run, it had legs.
Yep.
Okay.
Yep. So when the compiler runs, it's like it's running it for the first time. The compiler never saves. At least with most IDEs, the compiler doesn't save. Every time the compiler runs, it basically deletes your previous binary file and generates a new binary file.
Okay.
There are certain IDEs, like we're using the NetBeans IDE, there are certain IDEs that will cache or save your previously compiled version. Like if you do iOS development, it will save, the compiler will try to run only when necessary to try and save you time. But sometimes that's not what you want. Sometimes what you want is to really do a fresh restart and just wipe the old binary and run a new run through.
Okay.
Yeah. Everyone good? Kevin, did I answer your question, or do you want me to explain a little more?
Yeah. Can you explain that again? I think I'm still confused.
Yeah, so Java has a restriction that says that the file name of the file, right? So this file name is called firstlesson.java. If the file is called firstlesson.java, it has to find a public class that's also named after the file name. So you'll see that first lesson is the public class here. Public is a very special keyword. I'll explain what that is in a second, right? I could have put class animal at the top. It doesn't matter. Above public class first lesson. But because this file name is firstlesson.java, it's going to look for a public class first lesson. Okay. If there are two public classes, the compiler, at least in NetBeans, the compiler will get confused, right? So if I said public class animal here, you'll see that this little guy pops up and it says rename file to animal.java. It's just a restriction of the IDE. Got
Okay.
it?
Yeah.
Okay.
Can we see the public class file?
Well, we're looking at it right now. The file name of this program is called firstlesson.java. And the public class is first lesson here. Yeah. Okay. So now there's something really cool that methods can do. What methods can do is that they can actually take what's called an argument. And these are things that you give to a method so that it can do its job, right? So let's see. I will make a new method called eat, right? And I created a new method here called eat, and it takes an argument. And what an argument is that this method says I can't actually run unless you give me something. What do you have to give me? An integer. And I'm going to call that integer amount of food. Okay? Now, I've declared a variable called amount of food in the parameters or arguments of the method. The arguments are within the open parentheses and close parentheses, and they're comma separated. So I could have put a second variable here called weight of food. It could have been anything. Now I can actually reference this variable in my program. So whatever you give to the eat method, it's going to be stored in a variable called amount of food. Then when the eat method runs, it's going to print out I ate how much food you passed it, pieces of food. So if I do this, oops, delete this, delete this. You will see I ate 10 pieces of food. If I change this to 12, I ate 12 pieces of food. What's happening? I first create an object called this animal that's of type animal, and then I instantiate it. I then run the eat method and pass in 12 as an argument. 12 is an integer. The computer will then run to here. It'll see, take the 12 and store it in a variable called amount of food. I run the program. System out println I ate plus amount of food, whatever stored in this variable, pieces of food. You guys get it? Follow me so far? Questions? No questions. All right. So you can also do this for a constructor. So if you do public animal int legs, now I do has a head equals true, age equals 1, name equals animal. Now here's the really tricky part. This is an instance variable. This is a argument variable called legs, but I also have an instance variable called legs here. So if I just typed legs inside of here, right, your computer gets really confused. Which legs are you talking about? Are you talking about the argument variable legs, or are you talking about the ivar legs? To distinguish between them, you have to use the keyword this. This refers to the ivar. Okay, so if I type in this legs, I'm saying this class, this current object, its legs, this field, is set to legs, which is this argument variable. Okay, so this keyword, the keyword this, refers to the current object that you're dealing with. And remember, because this is a constructor, you're generating a new object. So when the constructor is called, first an object is created, and then these fields are run. This refers to the current object. Okay? So now, because I have a constructor that takes one argument that's of type integer, I can actually put an integer in here, right? So you could put up 4. It's like magic. Beautiful. Questions?
I don't understand what you just did.
Okay. So I created a second constructor. Here's the first constructor. Okay. Here's the second constructor. The first constructor doesn't take any arguments at all. The second constructor takes one argument that's of type integer, and I'm going to call it legs. Okay?
Okay.
Now, I'm going to set the current object's legs field to whatever the user passes in as an argument here. So you'll notice that when I did animal, this animal, new animal, I pass in one argument. Because there's one argument, the computer will look to see if there's a constructor that takes one argument. And hey, there is right here. Right? I passed in a 4, so I go to the constructor that has one argument. I take the 4, I store it into the argument variable legs. I then take that variable and I put it into the instance variable legs here.
So you
now
could
it's
have
stored here.
you could have done that in the constructor. You could have done this legs equals legs, and also you could have done age equals legs, and
Yep.
it would have 4 legs and age 4.
Yep, correct. That's exactly right. Okay. So you can also do stuff like this, public animal, and you can put a bunch of stuff in. Int legs, boolean is not headless. That's a really bad variable name. Int age, string name, right? So this is a constructor that will actually take all 4 instance variables that make up the class. Okay? So now I do this. I do this dot legs. Legs. This, well, actually, I named them differently. So has a head equals is not headless. This dot age equals age. This dot name equals name. So now if I do 4 legs, yes, it has a head. Age is 10, and its name is going to be dog, right? So its number of legs is 4. Actually, I'll just do the name, so you guys will believe me. Name is dog. Okay. So this is really useful, and it actually reveals a secret that I haven't told you guys about, which is, what the heck is this? This is an argument that the main method takes. If you were to run the program outside of NetBeans, right, you could pass it an argument. So in Mac, how you do this is you go to Open Terminal, and then you do Java space your program name. So here it would be first lesson.java space blah, 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 blah. Now, whatever I type here, these get stored in the strings args variable, where index 0 is the first string, index 1 is the second string, and so on. So this is how you get programs to run dynamic actions, right? Because you are able to pass in arguments into the method, and then it can do stuff with those arguments. Which is also what's happening here, right? Int legs, blah, 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 blah. Does everyone follow so far? Are there any questions at this point? Luisa, Alina, you guys have any questions? Nick?
So, so when you use, when you look at has a head equals is not headless, you didn't use the this dot before it.
Yep.
Is this pretty much only to like differentiate between like this legs and legs? Like if legs had a different name, you could have gotten away with not using this?
That's correct. That's correct. Okay. But the this keyword actually does a lot more than just differentiate between variables that are the same name. This keyword, the keyword this, actually refers to the current object. So if you were to call a third-party library, so let's say that I had Facebook ID, the Facebook API installed SDK. Is it SDK? So it's I think it's API, I guess. Let's say I had the Facebook API installed on this machine. So if I were to do Facebook, right, dot authenticate this, right, I would then pass in the current object to Facebook's authenticate method. Okay. So you take the current object instance and you pass it in as an argument. You could have done it like have a constructor that looks like this. It takes an animal as its initial argument, right? You can see that I can actually pass in objects as arguments to methods. So in the Facebook case, the authenticate method would take an argument object. This is just an example. This is not how Facebook's API actually works, but it's just to show how powerful the keyword this is. The authenticate method takes an object of type animal, and I'm taking the current instance and passing it into this method. I could also do something like, let's see. Oh, what was the other one? It was name. Right. So now crazy! Look what I just did. Created a new animal. I generate a new instance using a constructor that takes another animal as its argument. So now the animal that I previously declared is being passed in as an argument to a new instance of animal. So this is why this keyword is actually really powerful, because you can pass in the current, what you're actually working on right now, as an argument into other methods. I know that was confusing, Nick. Did you understand that?
It's still pretty confusing, but I think I kind of got it.
Okay. Well, as like I said, this is probably the most conceptually taxing lesson out of the bunch. I'm gonna try my hand at doing 2 quick final topics. The homework is probably going to be a bunch of smaller questions, and you guys are going to have to explore how to generate classes and create constructors and create methods. But there's 2 final steps that we need to go over before we can finish object-oriented programming. So we're going to get into polymorphism and inheritance right now. So actually, we'll just do polymorphism for the time being. I don't think we have time for inheritance. Let me see. Actually, do you guys feel like this is a lot? Because if you guys feel like this is a lot, we could do another class that goes over the other 2 topics.
Yeah,
we can stop here.
This is a lot.
Okay. Okay. So we're gonna just stop here. Let me answer some of your questions, and then we can have another lesson that goes over the final two issues. So just to quickly review, to declare a class, you need to use the keyword class followed by animal, whatever the class name is. Then you declare the instance variables that make up that class. Okay? If you want to give those instance variables an initial value, you have to declare a constructor. To declare a constructor, you have to use the keyword public followed by the class name and open and close parentheses. You can then declare the initial values for that class. Everyone good so far?
Mhm.
Now, if you wanted to have one or more instance variables be set to something different, you can declare a constructor that takes an argument. So here I've declared a constructor that takes one integer as an argument called legs. I then set the current object's legs field to the argument variable legs value. And then I set the other values as normal. You can do this for a bunch of different values. You can also pass in other objects as arguments to methods, not just constructors. You can do it for anything, right? So here, I'm going to generate a brand new animal that is the exact same copy of another animal object. So this constructor takes an animal object called copy animal. I then set the current object's legs field to the copy animal's legs field. The current object has a head field to copy animals has a head field, so on and so forth. Does anyone follow that? Questions there?
Yeah, I don't understand the kind of the syntax. Public animal parentheses animal copy animal. What's the second animal doing there?
So this is another variable of type animal, okay?
Hmm.
And you're using it as an argument to the method. Remember, arguments are things that you pass to a method so that it can do its job. So you're saying that in order to run this method, at some point in time, the computer has to have declared a previous animal object. Okay?
Mhm.
That animal object then gets handed over to the method here and stored in an argument variable called copyAnimal. So in the example that I had, I declared a new animal object called thisAnimal, and then I pass it into the new animal constructor. Because the constructor takes the animal object type, the computer will then see, hey, does the animal class have a constructor that takes an argument of type animal? Do you want me to explain that differently? Did you follow that?
I followed that there.
Okay.
Thank you.
So now the computer's going to check. Let's look in the animal class and see if it has a constructor that takes animal as an argument. And what do you know? It does right here. I found it. So now I'm going to take that animal and store it into copy animal and then run these arguments. Or
Why did you need this? Why did you need this here 4 times? Because
good
it's not
point.
ambiguous.
Right, good point. It's not ambiguous, so you didn't need it. Got rid of it.
And what's the scope of this? Like like
This just refers to the current object. So in the case of copy, right?
Mhm.
Okay, so let's go through this line. Line 16, let's go through it step by step. I'm declaring a new variable called copy. It's of type animal. Hey, computer factory, let's create a new instance of animal and call it copy. Make it. How do you make it? You're going to use this constructor. Okay? So in order to give copy its initial values, you're going to use this constructor. Where is this constructor? Well, it's the constructor that takes animal as its argument. Let me see if I can find it. Here it is. Now, this is going to refer to copy, right? Because we're generating a copy object, the factory is trying to build copy. What is the current object that's being built? It's copy, and therefore this is going to be copy. Okay? I think it's better if I draw a diagram. I don't know how to draw a diagram. But,
I think I got it.
oh, there you go. I do the draw. Oh, my, are you guys there? Hello? Hello, hello, hello?
I'm here.
I hear you.
Yeah, sorry, my internet glitched out. Let's do this again. So, because I passed this animal into this constructor, it's basically like I did this. This animal, copy animal equals this animal, because that's the argument that I passed in. You guys follow that?
I don't see anything on your screen.
Do you not see anything on my screen? How do I kick this guy? Okay. Do you guys see anything on my screen now?
It's black for me.
How about now?
Still black.
Ugh. Can you guys see me at all?
It was working. Like 2 minutes ago.
How about now? Can you guys see me?
This is
Yeah, I
you.
see you. Oh,
Okay. Sorry, technical difficulties.
I
Can you
see
guys see
your
it now?
screen now. Yeah.
So, oh jeez, this is freaking out. Can you guys see anything anymore?
I see napkins.
Okay. So because I passed in this animal to the animal constructor, you guys see this line?
Yeah.
It's as if I did copy animal equals this animal because I take this animal and I put it into the copy animal variable. Okay. But I'm still trying to just fill copy, right? Because constructors fill objects with their initial values. So I'm still talking about copy here. So when I type in this legs, this refers to copy because it's the current object that I'm trying to make. Get it? Like this is like it's very hard. I mean, this took me like 2 years to figure out. So
so you need this or no? You don't need this.
I don't need this in this case because of the exact reason that you said, Tay. There's no ambiguity, right?
Okay. Okay.
Here there's ambiguity, which is
Okay.
why I needed this. But this keyword just refers to the current object that I'm making.
Okay.
Cool? Okay. So here's what's going to happen. I'm going to just give a bunch of question and multiple choice questions. Sorry, I'm going to give a bunch of multiple choice questions for the homework, just like homework 1. But if you really want to understand this concept, I highly, highly recommend that you guys just try generating your own class. Go back through this video, declare your own class, write your first constructor, just try assigning initial values. That's all you need to do, okay? Like I said, this is like one of the hardest things to conceptually understand. But the questions are just going to check to make sure that your understanding about what's going on is correct. Does that sound fair to everybody?
Sure.
Okay. Also, I know that everyone has had trouble with some of the homework. Cast here. It's like